Hi everyone, I just wanted to do a quick video. I sent your test back to you, but wanted to kind of go over some of the common mistakes. The first one I want to talk about is whether to use T or Z. Please keep in mind when we're talking about one population and you only use Z when you are given the population standard deviation. That would specifically be a sigma, and that would be the symbol that was used. If you are only given sample data, then you use your T distribution. When you are giving sample data, of course, it's a statistic S. When you are given population data, it's the parameter sigma. So this is pretty important. Some of you in the confidence interval problem used a Z-score from the Z table when you should have used a T, because if you go back and take a look at that problem, you were definitely given sample data. Where in problem 1, you're given population data, so it was okay to use the Z. The second thing with 2 populations, I did say you could assume standard equal standard deviations. When you assume equal standard deviations, you do what we call the pooled test. In other words, you're going to pool those standard deviations together. And of course, with the pool test, you have to find SP and you have to use the appropriate formula. If you take a look at your formula sheet, the pooled and the non-pooled are 2 different test statistic formulas. So please make sure you use the correct one. The same goes with problem number 5. That was a paired test. I thought I made it pretty clear that it was paired in the problem. And for that one, you have to use that last test statistic. That's from chapter 10 for the paired test. And that's the one that uses D bar. So just take a look and make sure, number 1, you're using the right formulas. The next thing I wanted to go over was critical versus p-value. If I don't tell you which approach to use to determine whether to reject or not reject your test statistic, then you can choose either one you want. There's a lot of confusion on ones that I specifically said to use one. Some of you went and used another one, or you got them completely confused. So let's take a look again. And keep in mind, all of this is thoroughly explained in the videos I have. And usually in each video, I do both approaches. The other thing is, the reason I draw those pictures in the video is because it really helps you understand the process. I expect to see those pictures on the test of the normal curve because it really helps me understand that you understand what you're doing. It also helps you get it. So for example, let's talk about critical first. I'm not going to do a problem, but I am going to kind of show you what I expect to see. When you're doing a critical value approach, all right, here's our normal curve. Let's suppose we have a right tail test for this one. It is the critical value that gets written here. And this is the number off the table. You know, if you're looking at a Z table, it's a Z score. If you're looking at your T table, you have to utilize those degrees of freedom to get the correct number. Then you take your test statistic that you already calculated. You already somewhere calculated your test statistic in the problem in the part before I asked for the critical or p-value approach. Now, if that test statistic falls over here for a right-tailed test, that's your reject. So I should kind of see the exact critical value. So for example, if you were doing a problem and the critical value was just 1.96, I kind of expect to see that 1.96 there. And let's suppose your test stat, suppose it was just a Z test stat, I'm just making this up, came to 2.01. then I expect to see 2.01. You're clearly now showing me it's in the rejection region, and you're showing me you understand. Now, with your p-value approach, it's different. Your p-value approach, of course, is going to be a little bit different. All right, so again, we'll just do a right-tailed test just for reference. When you're doing a t-value approach, it's your actual test statistic that gets written here. So, you know, I tried to explain in the beginning of the course and do it throughout the videos. It's really important you understand the terminology in statistics. The test statistic is that value you found. It's a z-value or t-value. This upcoming week, you're going to get into chi-square values, f-values. That's your test statistic. All right, so when you're doing a p-value approach, it's your test statistic that goes here. It's your z or your t or your f or your chi-square, whatever you calculated in part 2. The p-value itself is an area. It is an area. It is between 0 and 1. If you're giving me a p-value of 1.5, I'm taking all the points off. Clearly, you didn't understand what a p-value was. All right, it's an area. In a right-tailed test, it's this area. So what you noticed is when you use the technology like StatCrunch and the computer, you can get exact p-values. If you use your calculator, you can get exact p-values. But often, unless you're doing a z-test, if you're doing a t or a chi-square or an f, you're going to get approximations. You're going to say, oh, all right, p is greater than I'm just going to make this up, 0.05, but less than 0.10. And you can get that off your table, which if you watch my videos in detail, I do go through how to get numbers off your table. So please take the time on your test to actually go through the process of whether you should reject or not. And of course, if p is smaller than alpha, you reject. If p is greater than your alpha, you do not reject. All right? So again, please pay attention to that because we're going to be doing, you know, once you get that test statistic, part 4 and 5, which is doing critical or p-value approach, and that interpretation of part 5 is going to be exactly the same in this whole next set of tests and problems. So, of course, the last thing I want to talk about is that interpretation. And again, I know I pointed this out in all of my videos. There are 3 points to an interpretation I expect to see in every single one of them. You must give the significance level, because if you don't give the significance level, you know, depending on where your p-value actually is, you could reject for one significance level, but not reject for another one. So it's a good idea to start at the, whatever it is in the problem, I'm going to say 5% significance level. All right, so that is the first thing I want to see. And again, I know I went through this in the videos, but I want to point it out so you don't make the same mistakes on the next test. Now, if your conclusion was to reject, then you would say the data do provide sufficient evidence. Because remember, this conclusion is only coming from this particular set of data. So it's important to say, hey, this data do provide sufficient evidence. Now, that's for reject. Okay? Do not reject, the data do not provide. So please remember to do the correct one. If you're rejecting, your data do provide. If you're not rejecting, your data do not provide sufficient evidence. All right. So that is part 2. Whether your do or do not actually correlates with whether you reject or not. So the next part, put your answer in context of the problem. At the 5% significance level, the data do not provide sufficient evidence to conclude. Don't say the mean should be rejected or the mean should not be rejected. That, ... I'm just going to leave that open because it depends. That, students, I'm trying to think of a problem, that the cans provided 14 ounces of beans, that students, that men watch more TV than women. It's whatever is in the original question you're being asked, but use context. Tell me what the problem is about. To conclude that drinking orange juice increases vitamin D levels, or drinking orange juice doesn't increase vitamin D levels. Whatever it happens to be, put it in the context of the problem. So that's a third thing I'm expecting to see. Statistics is kind of less about the math part and more about the understanding, and this is what really comes through in section 5. So hopefully these little notes will help you as you progress, because the next test we take will be all hypothesis tests. All right, you'll have some proportion, some chi-squares, and an analysis of variance. But it will be like 5 hypothesis test problems. So this part 4, so the last part of every hypothesis test is what you see here, the critical or p-value approach and the interpretation. Okay, please review your exams. And of course, if at any point you want to go over it with me in detail, just send me an email and we can set up a time to do that. Thanks.